So welcome to our talk, Eclipse versus the mobile world. My name is Jordi Lopez. This is my colleague, Holger Staudacher. He is responsible for the server side of things, of Tabris UI. Was also involved heavily in RAP. I'm responsible for client-side development for the iOS client. We have many more colleagues responsible for Android development and in the RAP team, of course, for browser clients and so on. So we talk about mobile development, and what we really mean in most cases is cross-platform app development. But cross-platform development has two sides. So there are some problems with it if you want to address multiple platforms. One is different languages, you have to use different tools, you need to learn different skills. So you notice this if you want to develop applications for iOS and Android, for example. Other problems are like you need to use different hardware to deploy and develop your stuff on iOS development. You need to have a Mac to do that, so you can do this from an Ubuntu machine. And yeah, most times, if you address new platforms, you need to learn everything from scratch, and this is a huge pain. And this was solved like years ago when Java was introduced and SWT. So you have one language, one IDE. You can build up experience, you can reuse for all your platforms you want to deploy your software on. And of course, the whole workflow and build infrastructure and everything that evolves in your workplace can be reused there as well. So I talked about SWT, but SWT is really old-fashioned, so it's so 2001. So it was a key to success at that time because it used native widgets. Native widgets mean you have a great look and feel, you have fast performance, and all the other benefits from native applications. But you still keep, because of the layer of abstraction, you keep the multi-platform functionality, or yeah, you can still develop multi-platform applications. And it was at that time not like Swing that was kind of slow, it felt not right, it just tried to imitate the look and feel of an application. And people or users noticed that, and this was the key to success for SWT. And now let's go some years later. We started the remote application platform, also known as the regex platform in the beginning. So we started 2006 with the first implementation. And we said, okay, so this concept of building something cross-platform, just describing the UI using SWT widgets and so on, let's use this for the web. So we built RAP. With version 1.0, we achieved our goal to have the whole workbench, you know from RCP applications, you know from your IDE, to have this working in your browser. A year later, we released RAP 1.0, and this was, at that time, it became an official Eclipse project. It was the first official release there. And we also used the SWT namespace for some things there to enable single sourcing. In 2010, we saw that the analogy of having a workbench in your browser is not working. So people don't want to have a workbench in the browser. It just looks ugly and it's just too noisy. So we focused more on the web side of things, and it became kind of a web toolkit. So we made it more lightweight. You could build applications that looked more like web application and not anymore like an RCP application running in your browser. And then the most important step in our evolution was in 2013, so this year, when RAP 2.0 was released. And with this release, we removed the dependency on browser, JavaScript, HTML5, style sheets, all these web technologies. We got rid of that and ensured that the server talks with the clients just with JSON. And what this means is basically that, like I said, we have our server running RAP and SWT API. Your application runs on the server. It talks JSON over HTTP. And JSON is like, yeah, it's a structured information. That talks to the clients we have. And there are different clients you can imagine here, like mobile devices, iPad, iPhone, desktop systems, browsers. They can talk or they can communicate using JSON format over HTTP. And so this enables us to have different clients with one single server, one single application running on the server. So it's like a thin client approach, you know, from the 70s, but just amped up a bit and adapted to newer technologies. But then we realized once we had this server, you can implement your application. Then you have multiple possible clients, like a browser client that uses HTML and JavaScript to render the UI. We had iOS and Android clients implemented in Objective-C and Java accordingly. We noticed widgets are not enough. So widgets are just the smallest building blocks of your application. If you want to build business applications or just anything bigger than one shell with a hello world or just one list, you need some kind of abstraction. It's not enough to just have buttons and labels. And this was already done for us in the past. It's called RCP, so our workbench. We have a lot of reusable parts there of UI. We can just declare that we want to have a view and just provide some content here and there and place some widgets inside this framework, and everything was fine. So you could build huge applications that looked the same, that felt the same, that had the same standard of quality. And there are more abstractions, of course, available than RCP and the workbench. We have Rihanna, Scout, and so on. But for mobile devices, this analogy is somehow a bit too heavy. So you don't want to fit a workbench onto your mobile devices. So you don't have that big screen, so you don't have enough real estate. It's just too overloaded. Mouse and these desktop concepts are from a decade ago. They don't apply to newer devices. And of course, it feels alien to the users. So there are no gestures, no animations at that extent that people would like. And all these innovative navigation concepts are missing there. So we needed something really lightweight that fits a mobile device or the browser as well. So you don't want to have these heavyweight UIs in your browser. So the focus we had here was to have lightweight UI, to have an abstraction, of course. It should be simple, clean, efficient. And yeah, people should not see a difference if they use such a framework, such an abstraction on their devices. They should just feel like at home. And this is what we built with Tabris UI, and this is the main topic of this talk here. But I want to give you an overview of what's available out there. So we have the RAP server. So this is basically our foundation we built on top. It's open source. Then we have the browser client that I mentioned earlier. It's based on HTML5, JavaScript, style sheets. This basically does the talking to the server and displays your UI in the browser. Then we have Tabris, also open source with a GitHub repository. You can check this stuff out. And this provides some additional widgets like GPS, like geolocation, camera support, everything you would expect from a modern device, plus some additions on top of that is beyond services and widgets. That is the Tabris UI, which Holger will show you later. And we have also the iOS and Android clients. These are closed source. They are commercial, not open source. But they talk to the server as well in the same way as the browser does. And then we have, of course, the Tabris UI client for the browser. So if you build something with Tabris UI, it's not just limited to mobile devices. All its navigation concepts with some things sliding in and out and so on can be applied or can be used to the, in the browser as well. So this is open source, and this is what we will show you now.
First, I have to switch the microphone because we only have one. Does it work? Yep. So, who's familiar writing SWT code? All right, that's good. Because this is what we do now. We write SWT code. I just need to, yep. So, all right. As Jordi mentioned, I will show you the Tabris UI, a live coding session of it, and we will create together a bookstore application. And when I think about a bookstore application, the first thing that comes into my mind is a list of books. So I prepared a simple application frame. This is basically a minimal RAP application. We have to implement this interface. It's called application configuration, and in this configuration, you register your application's entry point. And this is what we do here. So we just say application at entry point, and we need a pass. I choose store. And usually, you will pass in the class object of your entry point implementation if you implement a RAP application. But we want to create a Tabris UI application. So we provide API for this, and you just say, I want to add a Tabris UI entry point factory, and this needs an object called UI configuration. I create a method to create this object. Can you read the code in the last row? All right. So, and the API needs some properties, but we just can pass in null here. So our task basically is to create this UI configuration here. And you can think about UI configuration as a container that contains the description of your UI. So the Tabris UI has two concepts, really easy. The first one are pages, the second one are actions. A page basically is responsible for displaying your UI content, so this is where you create widgets. And the action is comparable with a workbench action. It just has a UI representation, and if you click on it, you can execute some code. So the first thing we do here now is create an UI configuration object, and of course return it. And we want a book list page, so we have to create a page configuration. And I have prepared some constants. We need an ID for it, so a string. And of course, we need the class for this book list page. So I say book list page dot class. And I have to create this class. It's here. And it needs to extend abstract entry point or implement an interface, but the abstract class is just fine. So I told you that, oh, of course we need to, this is the book list config, and we needed to add it to the UI configuration, book list page. And I told you that the UI has two concepts, pages and actions, but we have two types of pages. And these are top-level pages and normal pages. You can think about it, the top-level pages are the first layer of your application. And from these top-level pages, you can dive deeper in the application. You can create a flow of pages. So the Tabris UI needs one top-level page to be able to run. So I just use this Fluent API here and say set top level true. And basically, I can start the application the first time. Go in my browser. Oh, I need to adjust the size. And I have my first application. It's just a blank frame because we haven't created any application code here. But we will do it next. So the first thing in here I can do is say set title book list. And when I go to the browser, I think I didn't start it. Oh, wrong location. I say book list config set title book list. And I'm here. You see the title of the browser window is book list now. And of course, a book list page should list some books. So I will use simple SWT buttons for it. So our button is now our book. And I just display, let's say, 10 books in here. So I loop and say new button. Then with parent SWT push. I call it book. And I say book, set text. This is book number I. So when I go back to the client, list it, you see we have 10 books now. I can add a layout to my parent, set layout, let's say a row layout with SWT vertical style. And we have our 10 books here. So if you imagine a book list, when you click on a book, you'll probably want to see the details of this book. So with the Tabris UI, you can display the details in a separate page and just open a page when you click on a book. And for this, we need to define just a new page as we did it before. So we go back to our configuration and say new page configuration, and this is the details page. I also call it details page.class. Need to create it. And as the same with the list page, we just need to extend the abstract page. Implement the method. So this is the details page. And of course, I need to add it to the UI configuration. Details page. So, let's see how it looks like. No. Of course, when I click the button, the page should open. So I need to add a selection listener to my button and override widget selected. And here I can just call open page, and I have a constant for the page ID. And this is the details page. This is it. I start the application, run it, and when I click now on a book, it should open the book page. You see, it opens just another page, but it has no content. So this is the next thing we can do. We want to provide the details of this book. And for this, we need to pass data from one page to another. And we simply can do this by, say, new page data. Page data, and we say page data set. The book was, what do we take? The text of the button. And we pass in this data into the open method. Page data. Within the details page, you can see in the create content method that the page data, there's a second parameter, the data. And this is the data we passed in from one page to another. So let's say we can add some details, and we do this with a label. Parent SWT none. These are the details. Set text. And now we can say data get, and this was the book, and it's a string. Of course, I need to add some layout to the parent, set layout, new fill layout. So let's see what happens. Probably I need to restart. Here you see the label. We have passed in, we have clicked book 0, now we click book 1. So we can transfer data from one page to another. And now the cool thing comes in. And this is that when you access the same application with your mobile client, it renders using native technology. You know, the Tabris UI just has the concept of pages and actions. And the way they display it are up to a client-side implementation. So on the Android client, it will be displayed using the action bar, which is the native navigation concept of an Android application. On iOS, it will be used using UI view controllers, which is the native counterpart on iOS. And on the browser, of course, we can render the UI using HTML, JavaScript, and whatever. So we have the same application running on two platforms natively. And of course, this is just a simple application, but we can make it much, we can give it a little bit of love. So I've prepared a util, which I changed now here. I just changed my previous implementation. And when I go back to the application again, it can look like this. It's all SWT and JFace underneath, so we can use JFace tree viewers, table viewers, whatever, because we're just using SWT API. And this is how a book details page can look like. And as I said, you can dive deeper, so you can create a chain of pages and navigate back, as you see. And of course, this is just a simple example, a bookstore demo. It's also powerful enough to create complete business application. And we have brought some examples. I just changed the URL of my RAP application, of the server where the RAP application runs. And I go back to the client. And I see we have implemented a shop for a customer. And this is all SWT. So we can view some details, do swiping. And the thing you see here are actions. So we have implemented some kind of search action. You can search stuff like point and, oh, no results, nice. Whatever kind of works. You can dive deeper. You just create pages and chain it as you want. So I think this is it for live coding. You will take over. Oh, the browser. Sure, of course. Localhost 9090 TS. You see, it's the same application rendered with HTML. We also support the search here. And it renders using JFace, so it's the same application.
So as you saw, with the same code, you could build an application for your browser using HTML, and you could build applications that run natively on mobile devices, like an iOS device. And there are many more possibilities for that, because we have a server that just talks JSON, and JSON is a very small footprint description of the UI and the events that happen. And we have this thin client approach. You could hook up all kinds of different devices to your application server, like, for example, legacy hardware, like this caching system here that has a very not much capable computer built in, but you could implement a Tabris client for it that uses these concepts and SWT widgets to display information. Or you could use this in entertainment systems, because we also have a video widget. So you could build such systems. Or of course, if you're a more nerdy guy, so you could build one for your C64, your Commodore machine you have in your basement still. And yeah, of course, because it's networked, you only have everything running on the server. If you need to make some security enhancements, patches, update your software, you don't need to deploy this to all your machines or mobile devices you have out there. You just update the server, and every client gets the new logic, the new UI, because the state and business logic is held on the server. So this makes it much easier. And so, yeah, that's basically everything from our talk. So thank you for your attention. Please don't forget to vote for us. And yeah, now I think we have 7 minutes left for questions. So go ahead. Anybody? Yeah?
So the question was, what's the base technology here? And I said, for Tabris UI, the base technology is RAP, and RAP uses just servlet technology. We have a connector that you can register applications using OSGI services and so on, but it's really just you put it in your WAR file and deploy it on a Tomcat or whatever. More questions? Yep. The question was, can you build it with Maven? Yeah, of course you can. Everything you saw here is available in Maven Central. So you can just do your normal web application. Or we also provide P2, so if you're familiar with Tycho, I assume you are, of course you can build it. Yep. It's no special requirements. It's just a jar, you know. RAP itself just is one jar, and Tabris is just another jar. So all you have is two jars, and you can go.
But it depends as well. So if you want to use your JFace viewers for your tree or virtual tree, if you have thousands of entries to display in a list, you also want to add the JFace bundle, for example, to use that. So we support that as well. So the list you saw with the books, these are JFace trees.
So the question is, how do you handle dependencies? If you create an OSGI-based application, of course, you use the manifest. Everything you saw comes as OSGI bundles because you're an OSGI company. And if you do a Maven project, you handle your dependencies with Maven. So you are free to use the technology you want. As I said, it's just a jar. Everything else is up to you. Okay, more questions? Yeah. Okay, so the question is, how do we compare Tabris or RAP with applications built with PhoneGap? So first of all, PhoneGap is not a UI technology. So you're basically talking about HTML5 applications. And HTML5 is fine. We also do HTML5 applications, but you can't render the HTML5 application natively, you know, using native widgets or native navigation concept. And this is what Tabris is all about, using the native facilities. So we have a Java side abstraction of it, and it just uses the native stuff to render. And this is not possible with HTML5.
Yeah, it's a bit like SWT. So in SWT you have your Java API you can use, and then you have your JNI bridges to the operating system, and you have your DLL or whatever library according to your operating system that's responsible for displaying it with the technology that's available on Windows, on GTK, on Linux, or whatever other operating system, Motif, and so on. And we do the same. We have our server that has Java API, SWT API, and it sends over HTTP JSON messages to the client and tells the client, please paint a shell there, please paint a button there, and please notify me if somebody clicks that button. And then the client uses its most appropriate technology to display the contents. On iOS, it uses all the iOS widgets that are available there to render and interact with the user. On the browser, of course, we don't have native technology, so there we use HTML5 and JavaScript and so on to communicate with the server and display the UI. So we choose the appropriate technology for each use case.
Yeah, you know, Jordi said before that we have API for GPS locating and using the camera and whatever, and all this is also possible with HTML5. So when we run on a mobile client, of course we use the native camera implementation, but if we run with a mobile device, we use HTML5. So it's just an abstraction, a Java abstraction. Right, one more question? Yep. Can you talk a little bit louder? Okay.
Yeah, so the question was, how demanding is it to write your own client for Tabris, or yeah, for RAP basically as well. So we did this in past winter. We built a prototype, a Windows mobile implementation in about 2 to 3 weeks. It was just 1.5 person sitting there. So JSON message, so for every operating system, even the Commodore 64, there are JSON parsers available. So yeah, that's all you need basically, and then you can go on with your own technology.
Yeah. And it's interesting technology because it provides you a migration path. You know, we have some customers that have a lot of, what's the English word, register custody? A cache machine. Or industry PCs. They have 50,000 legacy devices, but they want to support their customers with new touchscreen-based devices. So, but they can't just throw away these 50,000 old devices, so they need a migration path. And with this, they can just build a new application, and we provide a client for the old machines that runs, just interprets our JSON messages and renders the UI. Yep.
Yeah, one more thing just to clarify this. So we even have an SWT client for Tabris. So there's an SWT, there's no HTML5 involved, for example. So yeah, thank you for your attention, and have a nice few hours left of the conference.
If you have more questions, just join us later.